So that said, settle in. This is going to be a great final day, and we're going to start off with a wonderful presentation about containers from Shang Liang.
Thank you. Good morning. Thanks a lot. I'm really honored to have this opportunity to speak at CloudEXPO again. So I kind of really started my career, started my journey with cloud computing with CloudEXPO. And this is the very first CloudEXPO I attended was the one in 2008. And one thing that CloudEXPO as a company, as an event that does very well is they always accompany the event with a lot of social marketing. And back when in 2008, Twitter wasn't that big, so what people, I guess, used to do is they post these blogs, post these articles. And it's kind of interesting looking back what CloudEXPO had to explain to people back then to get a show like this going. I did a search, and the articles that came up related to CloudEXPO in 2008 was articles like what is cloud computing, and really take a lot of explanation. And back then, the terms that are actually better known than cloud computing, as you can see just on this slide, it says terms like grid computing, utility computing, virtualization, clustering. Those terms are actually much better known than cloud computing. So people use that to explain what cloud computing was. I love CloudEXPO because it is also part of a big series of events. I mean, they tend to really have their pulse on where the technology is going next. And that's why I'm really very happy to come back here and talk about containers, which is, we believe is actually happening right now, and it's going to be much bigger going forward. And it is a very much of an integral part of evolution of cloud computing. The 2008 CloudEXPO was really the first one that I attended. I remember it was at San Jose Fairmount. It was much smaller. It's a much smaller venue. They didn't really have big ballrooms like this. The exhibit hall was very small. Everyone was in the corridor, but you can really see there's a lot of interesting things happening. And it was exactly around that time that I started my last company called Cloud.com, and we created a piece of software called CloudStack, largely inspired by our desire to essentially emulate AWS. In 2008, AWS was only 2 years old, just about the same age as what Docker containers are today. Docker is about 3 years old, so but it was already clearly taking off. And it inspired folks like us and a bunch of other people to start developing software that bring that AWS model to everyone else. So our thinking was, if AWS could be so successful with, we had no idea back then Amazon Web Services today is going to be as successful as it is today. We thought it was going to be big, but to be honest, we didn't realize it was going to be that big. But we thought it was cool enough for us to create some software to let other people stand up AWS. So if you heard about projects like CloudStack, OpenStack, it all kind of started around that same time, and we were actually quite successful. In about 2 years, we really landed a large number of customers and many more users. I think these are some of the paying customers from the largest service providers and managed hosting companies that used CloudStack to build public cloud. They would build a cloud really. Back then people were literally trying to put up their own, because AWS back then was a lot simpler. So it didn't have the 50, 100 services it has today. It had a handful of services. So it was relatively easy for someone like Korea Telecom or British Telecom to come in and say, I want to build my own cloud, and it would be, since I control the data center, I control the network, there are some things I'm actually even better at than AWS, so I'll try to compete with it. So there were a lot of public clouds, and then there were probably even more private clouds. Companies like J.P. Morgan Chase and Citi and Apple, and a lot of small companies really kind of came together, start building their own mini AWS. So it was very exciting. But so now many years have passed. I would say I like to kind of stand here and reflect upon that experience. One thing I think it's becoming increasingly obvious is that whole effort really didn't achieve the goal we set up achieving. And I'm only saying that because I'm going to kind of use this to lead to a container discussion. Remember, our goal is to enable a lot of organizations build clouds like Amazon Web Services. But if you kind of look at, this is the latest, August 2016, Gartner Magic Quadrant, which has, I think, 14 or 15 of the world's leading public cloud providers. This is out there on the internet. It's widely known. Of course, Amazon Web Services and Microsoft and Google, those are those are leaders in the space. I think Amazon Web Services alone probably dwarfs the rest. But there are a few others that Gartner categorizes as niche plays, and I kind of, when I start looking at it, I started thinking how many of those clouds are actually built on technologies that we developed, right? Because we were developing open source software that enable people to do exactly like that, and we worked on CloudStack and OpenStack, and there are like two actually. There's NTT Communications that's built on CloudStack, and Rackspace built on OpenStack, and actually went back a few years ago. The same Magic Quadrant looked a little different, had a few different vendors on it back then, and we had actually more CloudStack and OpenStack presences. So it just seems like the trend line doesn't look very good for these third-party public cloud provider that are actually going to be able to stand up and offer an alternative to AWS. And we actually think it's very important. Remember the very first slide I put up, I said, when cloud computing got started, when CloudEXPO was trying to explain what cloud computing was to the rest of the industry, we used terms like utility computing, right? The whole idea was computing is going to be like water, like electricity, like air, like a commodity, right? Everything is, we say it's a commodity, it's a commodity, it's a commodity. And then you look at something like this, it isn't. So what happened? I said we didn't quite achieve our goal. Is I think increasingly it's looking like today public IaaS cloud is becoming a winner takes all game, and then you could still say we still have private cloud. Private cloud, I think technologies like OpenStack and CloudStack have done significantly better. But even in that world, if you look at what technology really rules the private cloud, it is VMware. But overall, I think even as successful as private cloud has been, largely the industry view is private cloud is going to largely starting to lose market share to public cloud. So that's that's kind of the reality we're in today. And a fundamental statement, I think this is Lydia Leong, from the person who came up with that Magic Quadrant I showed a couple of slides ago. Very well-known analyst from Gartner in the cloud space, and I think she puts it very succinctly. It's not a problem, but it's just the reality. Cloud IaaS is not a commodity, which basically means it's cloud computing, we used to say it's kind of like utility computing, except it's even better. It has APIs and all that stuff, on demand, but it's not really utility, if you think about it, and that has implications. I think ultimately we believe, as successful as it's been, it's probably going to impact its growth at some point, right? So this problem has bothered, I think, the entire industry for many years, and frankly, there's not been a very good solution to. I mean, if you I believe this is a problem, and some people probably don't believe this is a problem, but I just think fundamentally that our original vision of cloud computing is we just got to all be able to consume these things as resources, and there's got to be a variety of providers, there's got to be choices, and it's got to be somewhat interchangeable, and it's just like anything else that you consume, and it just. Right now, the whole industry is early enough. People are honestly a lot less worried about things like lock-in, things like proprietary APIs. But at some point, lack of a vibrant set of competing providers, I'm afraid, is going to probably impact the growth of this industry. So, but how do we get there? We don't really know. So we were. I mean, I think for about 3-4 years, I myself personally was actually quite bothered by this. Not only, the fact that I couldn't figure out a way to really make these private clouds grow or make those alternative public clouds successful, make clouds like AT&T and Verizon more successful. I mean, when is the last time you hear these great companies like AT&T and Verizon who do offer a lot of other commodity like communication services? They ought to be in the cloud business, right? But they don't seem to be. Maybe at some point they played, and sooner or later they somehow started to disengage. So how do we change that? In the meantime, something dramatic happened. It really happened very recently. Even though Docker is as a technology, I'm sure many of you have heard, it's container. It's a particular type of container technology. People always like to say containers have been around for a long time, but just like virtual machines have been, and people used to say virtual machines have been around since the 1960s. IBM did it first, but it didn't really become popular until VMware, then later Amazon really made it popular. And same, I think, with containers. Containers have been around for a long time. Solaris did it. A lot of other Linux have been doing it for a long time. Companies like Parallel, SWSoft, been doing it for a long time. But it's about 3.5 years ago that Docker started, and the growth of Docker didn't even really start until maybe about 1.5 and 2 years ago, early 2015. It crossed that 100 million download milestone, and it just kept growing. We're not seeing the slowdown of Docker growth yet, and it has implications. I'm going to circle back to why I believe this is a continuing evolution of cloud computing, and the way it happened is the initial growth all happened from this thing called Docker, which is something like, I mean, I'm not gonna. I suspect you guys all pretty much know something about it to a certain degree, but think of it as a lightweight virtual machine or application packaging format. It doesn't matter. Whatever you think about it is probably correct. And then it has to run on some operating system. So I'm not explaining, with Docker is growing, it's causing the stuff adjacent to it to grow as well, right? So this is a brand new space. In the operating system space, it didn't used to be that interesting. It's very mature. Microsoft has the lion's share of the market, and then you have Linux, where Red Hat and Ubuntu probably has the lion's share of the market. But then all of a sudden, containers came along, and it actually created opportunities for companies like new companies like CoreOS. Even VMware created Photon OS. Microsoft created a new version of Windows specifically to run containers. We were one of the innovators in this space as well. I think I'm going to talk a little bit later, just give you a flavor of how something like Docker containers actually create opportunity even in the highly mature and highly stable operating system market. And we have something called Rancher OS. That's been very, very popular. So very well known. So this is kind of where it got started. And of course, ultimately, these operating systems run on clouds, run on infrastructure. And the nice thing with containers is it's really agnostic in terms of where you would run it. Of course, it can run on Amazon. I think these days, the vast majority of real DevOps workloads probably run on Amazon. So that's line share. But they also run on Google Compute Engine. A lot of it run on DigitalOcean or things like CloudStack and OpenStack. But a lot of it also run on premise, right? On bare metal servers, on developers' laptop, or on VMware clusters. So it really doesn't matter. Computing in this world is actually somewhat commoditized. So I'm going to come back to that. So there's some interesting implications there. So as it turned out, Docker is just kind of individual containers. So one of the hottest space, I saw there's actually a session today. I think Google and Kubernetes are going to talk about container management and container orchestration. Highly encourage you to go there because that is really the hottest thing that's going on right now. If you haven't heard about Kubernetes, definitely go to the workshop today and learn it. And otherwise, if you've heard about Kubernetes, you probably also have heard about Docker Swarm and Apache Mesos, and there are many more. These are just kind of ways. Think about these are almost like OpenStack, CloudStack of the container world, right? Like you have virtual machines, there you need these management software orchestration software to basically tie them together, which ultimately then people can run their entire DevOps workflow on top of the container technology. So this is kind of how the space is getting shaped out. So I'm going to first quickly talk about Rancher OS. It's a really interesting phenomenon, which is, we actually CoreOS as a company is probably the forerunner in this, but when container happened, it really started a movement to shrink Linux distros. Linux distros are becoming pretty big. They're pretty powerful. Like a Red Hat distro could be 4 gig. Comes in a DVD, right? Sometimes 2 DVDs. And then like even Ubuntu, they kind of try to keep it small, but it still comes on a CD. But really, you want to get going, you probably want to install some software packages that doesn't reside on a CD. And the CoreOS guys started it, and we really pushed it to the limit. Rancher OS. I think the most recent version of Rancher OS is just 42 megabytes. And it turns out that Linux kernel, it really doesn't take very much to run a container. So think about this is more like an ESXi for containers. And that's really all it takes. The Linux kernel itself at the very bottom is only 4.2 megabytes. And the drivers are actually much bigger because we do want to make sure this stuff runs anywhere. So the drivers are almost 3 times the size of the kernel itself. Then you have both the user Docker and system Docker. These are basically the Docker engine itself. That is the thing that you need to actually run containers. Then the basic file systems and tools like LSCP, those VI, you at least need a group of a small number of those tools to get the system going, and that comes to about another 8.4 megabytes. So it's really with that kind of distribution, people, I've seen people run thousands of servers, mission critical apps on systems like these. And why would they want to do that? Because when it's not just a matter of being smaller. To be honest, the disk savings is probably negligible. These days, what's the difference really between 42 megabyte and even 420 megabyte or even 4 gigabyte? It's not a big deal. It's an operating system. You install it once. But really, the lot more important thing is when things are this small, right? Number one, the most important thing, as Roger said earlier, is it's actually more secure. You don't really need to patch it. That's what Microsoft been saying. If you run Windows, patching is a big problem. Every day there's service packs and patches patches you have to download, and some of these patches causes causes reboots, and you just have to do that. And when it's down to 42 megabytes, you know, when the operating system is 100 times smaller, where you used to have to patch every week, now you patch every 100 weeks, right? And it just becomes a lot more stable, and then it becomes a lot easier to manage. There's just a lot fewer things going on. So you can see how actually this is just one example I'm going to use. You see how revolutionary, how potentially impactful a container technology is. And you know, like I said, operating system is a piece of technology that's very robust. I think people have been taking it for granted for years. And I'd never thought there were opportunities like this to dramatically push it to the next level. And now, like you guys, I mean, this is very real because we're a small company doing something like this. But then you see VMware, Microsoft, you know, all going the same direction, and Red Hat too. So you know something's really happening. Then I'm going to talk about the rest of the stack. And it's interesting because you know, you have things like Cloud Stack, OpenStack. Those are old cloud technology stacks, and with centered around virtualization. And now with containers happening, a similar kind of movement is going on. And to be honest, a lot of things are still in flux. So there are very interesting things happening. Like there are so many different ways to put these things together. So like for example, on the left, you know, I would say that's the mainstream way. You can actually run containers on virtual machines. That's what most people do. Containers is like a process. Virtual machine is like a server. So they run, and on top of a KVM, Hyper-V, VMware, there are multiple virtual machines, and then you run containers inside these virtual machines. But it turned out you can also run virtual machines inside containers. By the way, that's how Google runs, like on Google Compute Engine. Google actually manages the entire infrastructure using containers, and if you want a virtual machine, like Google Compute Engine, they'll give you a virtual machine, but they'll create it inside a container, and then they'll manage it like a container, and you don't really know. So and that's the approach we're taking as well. So pretty interesting how these things can swap around, and you know, technologies like Kubernetes and OpenStack are also, you know, they can also go different ways. I think what's on the left is probably the mainstream, is generally OpenStack takes care of infrastructure. Kubernetes manages the app. Kubernetes manages the containers. But recently, there's also been experiments, you know, done by actually OpenStack guys. They say, you know, OpenStack has kind of been difficult to configure and to upgrade. So what if we install Kubernetes directly on bare metal, and then we use Kubernetes to manage OpenStack? So that's, you know, kind of still at the experimental stage, but Mirantis is very serious about it, you know, so they're working on stuff like this. So who knows what this will lead to? So you can see the stack is still kind of what's happening, and since, you know, this is a cloud conference, and there are a lot of you know, you guys are probably reasonably familiar with virtual machines. You guys are probably more familiar with virtual machines as containers. There are actually really a lot of parallels, and the parallels especially true in how they deal with storage and networking. The storage is storage, networking is networking, and they're really quite similar. And then if you look at, you know, technologies like OpenStack that's been used to manage virtual machines, and technologies like Kubernetes and Swarm that's been used to manage containers, OpenStack has projects like Neutron and Cinder, has interfaces. Neutron manages networking, right? Cinder manages storage, and Kubernetes has very similar concepts. Kubernetes has a network interface called CNI, has a container network interface, and has a storage interface called Flex Volume, which is sort of like Cinder for containers. And Swarm, Docker Swarm, has you know, some of the same ideas, but different abstraction, libnetwork and Docker volume plugins. So the same, you know, the stuff people used to build for for virtual machines is actually kind of getting rebuilt again for containers. So if you guys go to the Kubernetes training today, I mean, hopefully they'll cover what CNI and what flex volume is about. Then this is probably the most dense slide I have in this presentation. I mean, you don't really have to look too much at details, but I kind of explain what this is saying. The basic setup this is trying to explain is we have two physical hosts, and then on the physical hosts we're running OpenStack. So the OpenStack is we're using OpenStack to create virtual machines. And as you know, OpenStack would use things like OVS, Open vSwitch, and Neutron, which is OpenStack's network virtualization layer to manage those virtual machines, network for the virtual machines. But then let's just say we run Kubernetes, we run Docker, and then Docker uses CNI, as I said, to run virtual machines, to do virtual networking. And now we kind of have a double overlay problem, because CNI would actually introduce yet another level of VXLAN. So you kind of have VXLAN running inside VXLAN. It works, but then some people say this may not be very efficient. So the OpenStack guys create a project called Courier, which would directly expose the OpenStack's own Neutron networking driver directly to containers. So that way you kind of eliminate the layer in the middle. You gain some efficiency. But we work with enough customers. I mean, there are actually much simpler ways to do this. What we're also seeing customer doing without bothering with things like Courier is you can very easily set up just simple flat layer 3 networking with containers. So that way there's not another level of overlay and tagging. So that's just probably more popular. And generally speaking, the kind of thing people like to do is they rely on virtualization platforms and cloud platforms to provide the multi-tenant isolation. And then when you're in a virtualization platform or cloud platform, you're already just one single client. So you don't really want to worry about isolation between your apps as much. So therefore, maybe a simple layer 3 flat networking would suffice, and then an architecture like this will probably work pretty well. And so you can see, the same problem. There's sort of a complex way of solving it, but there's also a simple way of solving it that doesn't really involve a lot of frameworks and code, and that's kind of been the nature of container space. People are generally very pragmatic, a lot more focused on what containers or what applications will require to run. A lot less focused on what the vendors, their equipment or their cloud platform has to offer, and we have to use those features. So container development tend to be more coming from the point of view of applications coming down, and then these things get translated into infrastructure requirements, then ultimately it gets implemented at the low level. So this is kind of a good example of of container networking. And next, I'm going to kind of talk about storage, and this is some information I found on the web. Intel talking about their as you know, in the last few years, storage has gone through some major transformation. From hard drives to SSD, right? But there's actually new storage technology. That's what this thing shows. The second row, 3D crosspoint, but I don't think it's quite in the market yet, but it's pretty close. It's basically talking about some new technology it's going to be orders of magnitude even faster than today's SSD, approaching the speed of DRAM. So I mean, things like that are kind of happening, and it actually translates. It actually really has an impact. And I think, technologies like virtualization it will be a challenge. I mean, they'll come up with solutions, but now you're going to have to keep up with the demand of the hardware. And containers, actually, in that sense, I think really has an advantage, because containers are basically processes. It does not require it does not involve another level of emulation, another level of, virtualization drivers. So what this is showing here is even Docker. This is probably, I think Docker from 6 months ago or 9 months ago already support this. Like, out of the box today with Linux, with Docker, you can say I start this container, and our limit, it's IOPS, read IOPS or write IOPS or read bandwidth or write bandwidth to a certain amount. So this, in the old days, these would be considered very, very advanced features. Storage vendors would spend years, and then implementing these in their system, and then you have to make sure they get properly integrated with these cloud platforms, and developers then have to figure out a way to use them. Whereas with Docker containers, again, because there's a lot of delayering going on, the system overall is becoming a lot simpler. It doesn't really take that much for people to start taking advantage of the latest and greatest storage technology directly from a container. So the whole point I want to say is a lot of the storage plugging, network plugging, security, all these operating systems, all these features that we developed for virtual machines nowadays is actually kind of being absorbed into the container technology stack. And the container technology stack is really grown. This is the most fascinating thing in our space. I mean, you go from the very bottom, computing resources, container operating system, then distributed database, storage, networking, security, container engine. Those are things like Docker itself. Container registry, that's the place you put container images, access control, monitoring, scheduling, orchestration. That's like things like Kubernetes and Mesos. It just grew. Like if you're a technical guy, you get into this space. It's a great experience, because you'll never run out of new technologies to explore. Every day there'll be exciting developments somewhere, but it also kind of creates some issues with, of course, with customer adoption. Right now, this is happening so quickly, so there's a great deal of confusion. What should I use? Should I use Kubernetes or Mesos? Those people have those kind of, I heard Docker has been the dominant container engine, but now there's Rocket. The VMware has this thing called vSphere integrated containers, which is also different. So which one should I use? So there's quite a bit of a confusion going on. But this is the exciting time. Just like when back in 2008, when CloudEXPO was trying to explain to the rest of the world what is cloud computing. So that's why I'm kind of standing here and explain what this container technology ecosystem is about, and how that kind of, this really, don't you think this mimics the cloud ecosystem a few years ago? Like back then, I would put things like, what used to be compute resources. Today, you see like AWS, VMware, OpenStack. For the cloud days, it will be like Dell, EMC, right? There's storage, networking back then would be like Cisco, and the cloud engine will probably be like KVM, Xen, Hyper-V, and then orchestration will be like OpenStack, CloudStack. So it's kind of very similar, but this is one layer up, and this is actually one of the things I'm going to explain what we're doing. This is really not a talk about Rancher itself, but I started, after going through that many years building CloudStack and building cloud platforms, I really think there's a huge opportunity here building container management platform that can really encapsulate a lot of these technologies. So people who want to put containers in production, do not have to get lost in the midst of all these technologies. So that's why we built Rancher. And Rancher does not include the operating system or the underlying compute resources, but it basically takes care of everything else. So you can just deploy apps and run your DevOps pipeline right on top. So I kind of want to summarize a little bit. If you think where all this thing is going, and I think if my theme for the talk so far has been containers are actually not that different from virtual machines from a conceptual perspective. It is at a different level, but generally they're simpler, they're smaller, they run faster, they're more secure, again, because it's smaller, and they're easier to operate. You can just specify IOPS directly on command line. Just a lot of the complicated stuff seems to have gone away. So this is very good. But I do want to kind of talk about one probably more significant implication. If you guys, so where this whole thing could be going. If going back to what I said in the very beginning, I mean, today the public cloud space is honestly speaking winner take all. So it wasn't that long ago. I think people were very concerned about the same thing on the computers as well, specifically on the desktop. If you think in the 90s, I think a lot of people are very concerned about Windows having too much market share, but now I don't think people are as concerned about it anymore. And the viable alternatives exist, right? Like a lot of people start using, they don't even use desktop anymore. There are a lot more Mac users, and there's tablet users, there's phone users. And I think a key technology that obviously made it happen, I mean, this would not have happened if it weren't for the browser. Back then, before the browser, all these applications were specifically written for the Windows desktop. It's very difficult for another platform to come in and try to take over. But with the browser and with the content that comes with the HTML and JavaScript content these days, it can really run anywhere. I mean, of course, I say it can run anywhere, but it doesn't mean they're always exactly the same. There are different flavors of. A lot of times, there's still. If you talk to a UI developer, he'll tell you there's still some challenges creating a website that can work on the phone and work on the desktop, or even between different browser makers. But it works well enough. It's a problem people are willing to solve, and works just well enough. So without too much effort, you can really bring this essentially completely portable content and apps across a variety of desktops and phones and laptops and tablets. So that's really kind of fundamentally changed the game. And this is why I kind of want to go back. I mean, the reason I started Rancher Labs is I was really kind of quite inspired by this and kind of try to learn from our experience. I really feel that, going back to what I said in the very beginning, we didn't quite achieve our goal of essentially seeing that cloud computing vision that, this conference had initially at the very beginning, which is really utility computing. Computing should become commodity, which means to some degree should be somewhat interchangeable. I'm hoping by building platforms like Rancher, I mean, Rancher wouldn't be the only platform that can do this, but hopefully by focusing more on the app side, focusing a lot more on supporting containers. And because containers, Docker containers, just like HTML and JavaScript, they're fundamentally agnostic to what computing platforms they run on, we could really make IaaS more interchangeable, and we could make cloud more like a commodity. We could come closer to realizing the vision that even this conference had almost 10 years ago, and which we're not really there yet. And ultimately, that brings. I mean, I don't think anyone could argue today's desktop experience and phone experience and tablet experience just so much more superior to the desktop-only experience that people had in the 90s, right? So I think hopefully the same thing will happen with cloud as well, and then that will bring cloud adoption and opportunities to the next level. So really, to just kind of conclude, I think with containers, I mean, this is why I said containers will usher in a new era of cloud computing. I think with containers, IaaS can ultimately become a commodity service. Could become what it's really designed to be, and could be called utility computing again. So that's really what I want to talk about today. I mean, thank you very much. I'll be around a little bit, and if you guys have questions, please feel free to come up and we could have a chat. Okay, thank you very much.